Hi, thank you so much for joining me. In today's session, we're going to be talking about a concept called conjugate pairs. And I'll be honest, this can be rather confusing, but it is so very important to understand when we have a conjugate of an acid or a base. A conjugate is a partner. If you're in a foreign language, you conjugate verbs. You partner verbs appropriately to whether it's singular, plural, and that type of thing. So it's been a long time since I had to conjugate verbs. So I want you to pay close attention and rewind this as needed to make sure you get it because it's really, really important. Okay, so most of the time we're going to be using a Bronsted-Lowry theory to define. So if it loses an H plus, it's an acid. If it gains an H plus, it's a base. And in the process of doing that, we form a conjugate of the original substance. So for a conjugate base is produced from an acid. So after acids do what they do best, I'm going to just use an HX for some generalized acid base. So when an acid does what it does best, it gives up an H plus. Well, what remains, whether it's strong or weak, is called its conjugate base. Now, if you will notice, when we are going in the reverse direction, so if we're reversing this reaction, this base is accepting an H and a plus. So a base is a base is a base. Whether it's a base or we call it a conjugate base and a base accept an H plus. So this is about terminology, but it's important terminology. So it behaves as a base in the reverse reaction, assuming that reverse reaction is possible. A conjugate acid forms from a base. So when bases do what bases do best, so I'm just going to call that a B, they like to gain an H and a plus. So in this case, just a simplistic generalized form, this is my base. This would be called, what is formed is called the conjugate acid. You notice in the reverse direction, this is acting like an acid. It's donating an H and a plus. So a conjugate acid is just the same as an original acid. It's terminology, but important terminology. They donate. Okay? Now, here's the key here. An acid and its conjugate base, or a base and its conjugate acid, differ by only one H plus. It's kind of like they're playing hot potato with this H plus, tossing it backwards and forwards to one another. Okay? If it's in a reaction, the acid-base terminology is used for reactants. The conjugate terminology is going to apply to the products. So let's take a look at an example here. Okay, so we have here in this example, HCl gave an H and a plus to water. So the HCl is the acid, the water was the base. Okay, so that's kind of the notation we're familiar with. Now let's take a look at their conjugate partners. Now this, once HCl does what it does best, it was an acid. What it forms is called the conjugate base. Okay. Now let's take a look at the base one. Water was the base. What it forms when it gains the H plus is a conjugate acid. Okay, so let's take a look at this next example. Identify the acid, base, conjugate base, and conjugate acid. Okay, so in this case, you notice phosphate in going from reactant to product gained an H+. So if it gained an H and a plus, this is the base. Its partner is a conjugate acid. Notice that they differ only by that H and a plus charge. So -3 plus 1 is equal to -2. So they only differ by that +1 charge and the H. Let's look at what happened to the water. The water is the acid in this case. It donated an H and a plus, and when it donated an H and a plus, it formed the conjugate base hydroxide. So if you notice, if you go in the reverse, it acted as a base. It's gaining an H and plus in reverse. If you notice here, if you do the reverse, it's losing an H and a plus. Okay? So an acid is an acid. Acids donate, bases accept. Okay, whether we call them conjugates or not. So let's take a look at another example of this, another couple of examples. In this forward direction, this is acting as a base because it gained an H and a plus, forming a conjugate acid. So you notice that in reverse, H2SO4 is losing the H plus, the base gains an H plus, and they differ only by that H and the plus charge. Now here, phosphoric acid is our acid. It forms a conjugate base. So you notice in the forward direction, this lost an H and a plus. That's why it's an acid. In the reverse direction, it is acting. Conjugate bases act like bases in reverse. They gain an H and a plus. Okay. In this next one, hydrocyanic acid. Hydroic, remember cyanide, ide goes to hydroic. So this is my acid. This is my base. Acids form conjugate bases. Bases form conjugate acids. Okay, so let's take a look at other ways you can be asked questions about this. In this question, it says determine the conjugate pairs. Well, if these are acting as bases, when bases go to form, bases do what they do best. They gain an H and a plus. So to go from a base to becoming a conjugate acid, you gain your H and your plus. You gain your H, and instead of one hydrogen, I have two, gain an H and a plus charge. Sulfate ion, gain the H, put it on the sulfate. We only do one H plus at a time. One H plus at a time. So HSO4 minus. Sulfate is SO4 2 minus. When it gains an H, didn't really have quite enough room there, gained an H, and it gained a plus charge. So -2 plus 1 is -1. Water, as a base, water, have you noticed water acts as both an acid and a base? That's interesting. So it forms H3O plus. Okay. Ammonia, in theory, could act as an acid, but it doesn't often. But let's just use it for practice. Acids lose an H and a plus. So to form the conjugate, it's always a loss for acids. So if we went through the mechanics of that, you'd get an H2 minus. Very little of that would happen. Add an H, so I have two H's. I'm going to add one H to that. It had a negative charge. -1 plus 1 is now neutral. Nitric acid is HNO3. So I'm going to lose that H. Whoops, I blew that last one. I'm going to fix it in a minute. And that plus charge. I made that act as a base instead of an acid. So erase that and let's fix that. I want this to lose an H and a plus. Wow, that's kind of interesting. That substance could act as both an acid and a base. It's an interesting thought. I better make it do what the problem said, though, or I would have got that one wrong. And this is an acid. If it loses an H, which is what acids do best, they lose an H and a plus. I have only one H, PO4, and I'm losing a positive charge, so that would be now 2 minus. Okay, water. This time water is going to be an acid. Acids lose an H and a plus, so I have hydroxide. So water can act as both an acid or a base. Be careful, because I almost got tripped up by that. Listen, read your questions very, very carefully, so you know if it can be both. We'll talk about that term later on in another video clip. If it can be both, you need to read the context of the question very clearly. Okay, so let's take a look. We're going to fill in this chart with the appropriate partner. So if I have a conjugate acids don't make acids. Conjugate acids came from bases, and that base must have been F minus. Conjugate acids don't have conjugate bases. Okay? So if I have a conjugate base, in terminology, do not have conjugate acids. Conjugate bases don't come from bases, they come from acids. So bicarbonate is HCO3 minus. So the acid, it's a base. So to find its acid, I'm going to add an H, because bases gain an H and a plus. So I'd have carbonic acid. Acids don't have partner bases. Acids don't have partner conjugate acids. They have conjugate bases. Acids lose an H and a plus, so I'd have HSO4 minus. Cyanide ion is a base, so it's going to have a conjugate acid, and that would be HCN. Cyanide is Cn minus. You add that H plus, and you have HCN. Now I have H2PO4 2 minus. It's acting as an acid, so it's going to have a conjugate base. So acids lose, I don't want to make that same mistake twice, it loses an H and a plus, so I'm going to have HPO4 2 minus, and I want you to note that that's a typo there. That should be just -1. So that should be H2PO4 minus 1. Becomes HPO4 with 2 negatives. Okay, so that's another way, if you don't have a reaction, that you might be asked questions. Okay, so that's it for this video clip. So thanks for joining me. I really appreciate your time. Take care.